Okay, functions of relations, lesson 4. Okay, so today is just a little step more than last class, and it just has one little kind of concept in it that's why it's kind of left by itself. Addition, subtraction, multiplication. You're not going to get what we get here, and sometimes when you divide something by something, okay, you get that thing on the bottom that's a 0, and then you can't divide by 0. So we've got to treat that differently. That's what we're really going to be talking about today. Now, here we are. We're going to do, just like you did on your quiz, we're going to take two graphs and divide them by each other. Okay? Now again, a weird concept, right? How do you divide graphs? How do you add graphs together? Well, that's kind of the, that's the grade 12 thing, right? It's the process that we're going to kind of take the picture, make it into a chart, and then it would make sense. Okay, well, yeah, we can divide numbers. I get that. Well, that's all we're going to do. So again, like on my quiz, you're not going to get that nice little chart on the side. You're just going to have to build your own. And you got to pick X's that are good to you, right? If you're building your own, don't pick 583 and 3.21 as your points. I mean, those are just like, what are you doing that to yourself for? Okay, so on this graph, I would say -5 to 5 would be reasonable. Now, we're going to kind of do the chart here. So the first one, when x is 4. Now again, we have two graphs on here, and we really want to keep them straight, because if you do mix them up, it changes everything. Now, not in multiplication and not in addition, but subtraction and division will mess you up if you screw it up. So I'm going to be very deliberate to say this red one is f of x. And the blue one is going to be g of x. And again, have I said bring a bunch of colored markers into the diploma? Yeah, so hey, if I'm making you use them all the time and we're doing them in class, then it's going to be reasonable for you to do this on the diploma, right? So this is kind of like, remember red divided by blue, not blue divided by red, okay? That's kind of easier because the f and x and g and x, that gets kind of confused sometimes. Yeah, I know it says it right beside it, but it still gets messed up. And actually, I'm talking more from experience of myself than maybe some of my students, but these are the things I put into place so I don't make stupid mistakes, because for some reason I love to make a lot of them. So you see we're 4. If we go with 4 over here, this point is right here. It is 14, okay, because 14 is right here, divided by 2, which is on that one. So it's 14 divided by 2. The next one at 3 would be, what is 3 hitting? What point would you say that is? 6. And what's it hitting on the blue line? 1. Okay, 6 divided by 1 is 6. And the diploma, I think, is nice enough to actually put those dark points in there, so you know you're not reading in between. Okay, let's do 2. At point 2, we get what divided by what? 0 divided by 0. Now this one's a tricky one, because people like, that has to be 1. Because we've always learned anything divided by itself is 1. But it's still dividing by 0. And if you really want to think about it, if I gave you nothing and I said divided by nothing, I hope you'd be very confused at that point, right? You're not going to sit down and get to work, okay? So that still is undefined. Okay, so let's plot those points. We've got 4, 7, 3, 6, right there. The next point we can't even do. Okay, let's do the next one. Let's do point 1. 1 is -4 divided by -1. Negative 4 over negative 1 is 4. So I have 0.14. Like I'm getting it, it's a line. And you'll see the next point, let's just do 0. 0 will be negative 6 over negative 2, which is 3. So I'm getting it, it's a line, right? But that one point doesn't exist. Like this point here doesn't exist. How do I graph that? Okay. Now, the first thing to do is like, where do I even plot the point? Now we can see the pattern going here. I can just see I screwed that one up. Okay. We can see the pattern here. It's a straight line. But at this point right here, we're going to do this. And then we go like that and like that. So undefined is going to be that. That's actually the entire concept today. Now, if you start doing the math, now I'm not going to go with the rest of them because I'll trust me, it's a straight line. This is the diploma, keep doing all the points. Okay? You don't want it to be going like that and all of a sudden going sideways. Okay? Yeah, don't be lazy in the diploma. They give you 3 hours, use it all. Okay. Now, explain why the domain of f over g is not the reals. And, you know, basically we're saying that right there. It's not the reals because x can't equal 2. Right? So we know it's not in the reals. It's not defined when x equals 2. Now, we did see already. Now here's the math part of it. Okay, x plus 6, or x squared plus x minus 6. So this is x squared plus x minus 6 all over x minus 2. Okay, now just for the fun of it, put this into your calculator and see what it looks like. Okay, and make sure you put the top in brackets and the bottom in brackets, okay? Because we need to learn how to use our calculator. And not just how to use it, but what does it do? Okay, so x squared plus x minus 6 divided by x minus 2. Okay, everyone's got that, and then hit zoom 6. Now, what's this showing? But, well, I don't have that little open thingy that you're just talking about. So now you know. Calculator doesn't give it to you, does it? Okay? So when you're in a diploma and you're graphing it, calculator doesn't give it to you. Okay? Now, but sometimes you can hit zoom 4, which is zoom decimal. And of course, zoom decimal doesn't work well unless I go on, and even when I change the window settings, but if it was in that little, so if I hit my window, so I'm like, okay, x max, let's make is 10, and y max is 10. It doesn't show it there either. Okay. So the moral of the story is that the calculator is useless for finding that little point. Okay. Now if I go back to zoom 6 again, if I just hit trace 2, 2 is the bad point, enter, see it doesn't give me an answer. It says that that doesn't exist. Now you're going, yeah, well, how do I just pick 2 out of the air? I don't know how. Okay. Well, you can go to your table and see one just doesn't belong there. Okay? Now again, I'm showing this to the people that want to get 100 on their diploma. This is one way to be able to check if you actually found the right non-permissible. Okay? Because it gives this word here. It's never a good word, is it? Okay? So, with that in mind, how does this work? Like, why does it give a straight line? Doesn't it usually give these loopy things with asymptotes and all that? Remember that last year? Okay, well, this is why. Okay, if I was to factor the top, remember, I'm looking for two things that add to give me 1, multiply to give me -6, and that is 3 and -2. So this turns out to be x plus 3, x minus 2, all over x minus 2. Now, does it make sense that x plus 3 is the answer? So F, G. But here's the kicker. You must say this right after. X cannot equal 2. Now again, there's an argument, right? I got rid of the x minus 2's. It shouldn't be a barrier anymore. If it was ever bad in that question, it is always bad in the question. Now, if someone just came up to me and said, graph x minus 3, okay, well, let me try that. Let me do that in y2. I'm just going to put in x minus 3. Okay? Now, just even make, I'm going to make that the dark, thick line. So it'll graph both now. I should probably graph the right thing, because that actually would destroy my whole point here. Okay, so there's the first one, and there's the second one. Now, on the second one, let me get rid of the first one here quick. Actually, I'm going to show you a trick too. So if I hit trace 2, I still get, that's my old line. If I hit the down, I should get the new line. Trace 2, no. There. Okay, so when you're in trace mode, it hit down, it goes to the other graph. Now you're thinking, well, I'm on the same graph, but it goes to the other one. See, 2, 5 exists for just x minus 3, but 2, 5 doesn't exist for x squared plus x minus 6 all over x minus 2. Okay? You get what I'm saying? Okay? So if someone just gave me graph x plus 3, there's not going to be any non-permissibles. But if I'm graphing x squared plus x minus 6 over x minus 2, that does have a non-permissible. Okay? And then what would be f of g -6? Couldn't be any easier than to put that in and get that. And I should be a good boy and put my brackets. So all we're learning now is, I don't know what we've learned so far. Calculator doesn't give it to us unless we go to table. And wherever there's a non-permissible that's making it not work, it stays as not working. Okay? That point, that open circle is called the, or hole, is called the point of discontinuity. Okay? So basically, hole equals this. Good thing to have on a study sheet. So actually, because you'll be surprised, if I don't talk about point of discontinuity for the rest of the year or semester, and then when I give you a practice diploma and they're like, find the point of discontinuity, you can be like, what? We never did that. I said, well, look at your study sheet, and there it'll be, point of discontinuity. Otherwise, you're flipping through your book trying to find that one page, right? Okay, so let's just do some here. We got 2x plus 5 over x plus 5. 2x plus 5 over x plus 5. Now this is a good question because it's so simple. It's so simple that most of you would get screwed up if this was the homework. Can I do anything here? No. So you're done. Okay? But there is one thing. This is f g of x. Okay? There is one thing I have to do, and that is state the non-permissible. X cannot equal negative 5. Anything that makes the bottom equal 0 is a non-permissible. And this is what this means. I'm not x plus 5 is not allowed to equal 0, right? Everyone agree with that? So then I do some algebra. Minus 5, x cannot equal minus 5. So you could actually use algebra to figure it out. Okay. This one here, can this be factored? Is there two things that add to negative 2 that multiply to negative 35? Close. Negative 7 and 5. So this is x minus 7, x minus 5, all over x minus 7. This crosses out. Answer is x minus 5. Yep. X plus 5 is the answer. And what am I missing? X cannot equal 7. Okay, so what's the domain of x? Can anything go in there? Or f of x, I should say. Can any x go in there? Is it allowed? Like, remember today we had that square root, so you weren't allowed to put in negatives. Is there any x that's not going to be allowed in there? Can you find anything? Okay. So every x would be allowed there. So x in the reals for this one and x in the reals for this one. The point of that is just because those two are allowed everything, when you take f and divide by g, yep. Because anything can go, any x is allowed in there. Like remember today we had like whatever square root x plus, right? See, this is saying I'm not allowed to be negative. So that puts a restriction on everything. But in this, any x would be allowed, and same with this. And if you graph them, you'll see that this is going to give a parabola, so you can see how any x is allowed, right? And this is going to give a straight line, so every x is allowed. Okay. Now, we want the expression in simplest form. Let's see if we can factor this. 2x squared minus 13x minus 17. Okay? Again, this is our only third day into math, and some of you may even forget how to do these. Remember, this is the what plus what equals negative 13, and what times what equals I'm like thinking about that. We didn't do that in the last class. I was like, okay, so what times what equals negative 14? Good. They are. Okay, so this is 2x squared minus 14x plus 1x minus 7. Remember, those aren't our numbers because this is a type 2 because there's a number in the a value that's not 1. Then I'm going to put a set of brackets around this, set of brackets around this. What can I take out of the first set? 2x. Okay, remember, take out as much as you can. That would leave you with x minus 7. The other one, okay, a 1 would leave you with x minus 7. Okay, it's always a good day when those things in the brackets are the same. Okay, then I'm going to take out an x minus 7, and that's going to leave me with 2x plus 1. Okay, so I actually haven't done the question yet. I just simplified the top. So my question is going to be x minus 7 over 2x plus 1 all over 2x plus 1. Oh, look at that. It just cancels. I get x minus 7 is the answer. X cannot equal negative a half, right? And again, for those people that struggle with those a little bit, it doesn't hurt to do this and then do your algebra, right? Divide by 2, divide by 2. X cannot equal negative a half. Okay, f of g 3 can be done two ways. The first way is just take the original, which would be 2 times 3 squared minus 13 times 3 minus 7. Okay, and I'm going to take that and I'm going to divide by 2 times 3 plus 1. Okay, now when you put this in your calculator, be very careful. You put the entire top in brackets and the entire bottom in brackets. Okay, yell out as soon as you get it. Negative 4. Very good. Okay, so that's one way to do it. And the other way to do it is just take your final answer and put it in. 3 minus 7 equals negative 4. Now, I think it's kind of obvious. Why didn't you just use the one you did all that work anyway? Why don't you just use it? And I would be scared that I'd get both of them wrong because maybe I did that step wrong, right? The other thing I would do is I would put I would put 3 in both and make sure I am getting the right answer. Okay, that's why they give you 3 hours for the diploma, because that at least last 45 minutes should be for checking it over. Okay, I don't know if I've talked to a lot of students, that wrote a test in class, and I'm like, ought to go, and they're like, good, but I didn't get to check it over, so I have no idea, really, right? And I think when we don't have that opportunity to check over a math test, we're just kind of going, oh, I don't know, because sometimes I make some stupid mistakes. So if that's what happened, and I wasn't able to catch them, then I guess I'll have to see when I get my mark back. Okay, now let's do two fractions or two ratios. Rational expressions are called, and see how that goes. Now, when we are just finding the domains of f and the domains of g, what's a domain of f? This is f, by the way. Is that the reals? Any restrictions? Yeah. X cannot equal 1. And for g, let's use colon. G, x cannot equal 3. Okay? Now, hopefully we're getting good at these now. This is 3 times fg at 2. Now, does everyone understand the 2 goes inside? Goes wherever there's an x, right? And 3 takes everything and multiplies it by 3. So what this means is 3 square bracket, okay, 2 times 2 over 2 minus 1 times, and I'm going to use just the dot so people don't get mixed up with x's and times, 2 over 2 minus 3. Okay, does everyone get that's what that means? Okay, and when we do that, we should get the answer. See if anyone can get it. Okay, What is it? Negative 24. Good. Again, make sure you're putting the entire bottom in brackets because there's more than one thing down there. And then make sure you're multiplying it all by 3 when you're done. Okay, write f plus g of x, okay? Now this is a pretty difficult question. Now before I start this question, I want to go back to grade 7, grade 8, okay? Because I need you to be able to remember how to add fractions. Now this is how you should have been taught to add fractions, okay? I need to add 1/2 plus 1/3, and hopefully I'm not getting 2/5, okay? Addition and subtraction have that nasty thing of I have to do what? A common denominator. Now, what's the common denominator? 6. So underneath, it should always work down. Underneath, I'm going to put the common denominator 6. Now again, I'm just going to grade 8 because I need, this is a rational expression using the grade 8 concept. What do you have to do to 2 to get 6? Multiply it by 3. What you do to the top, or what you do to the bottom, you do to the top. So 1 times 3 is 3. Okay? Everyone remember this? Now, what do I do to 3 to get 6? And multiply by 2. So you have to do the same thing here. 2 times 1 is 2. Now it's 3/6 plus 2/6. And I haven't changed the actual fraction. 3/6 is still a half. 2/6 is still a third. But until I get them as common denominators, I cannot add them. This will give me the answer 5/6. Now I need to parallel that question right beside so you don't think I'm doing anything new. So I am doing 2x over x minus 1 plus x over x minus 3. Okay? Below, I want to rewrite those rational expressions as fractions, just like I did with 1/2 plus 1/3. First, got to come up with a common denominator. 2 and 3 both go into 6. That's why they were common. What do x minus 1 and x minus 3 have in common? X minus 1, x minus 3. Right? So this has a common denominator, x minus 1, x minus 3. Now I got a few grade 11s taking this course this year, and this is where they have a huge advantage too, because we just finished rational expressions. They wrote a final on it. But I'm not going to change the rules. I have to multiply this by what to get this? So I'm going to multiply this by x minus 3. Do the same thing to the bottom as I did to the top. This I'm going to multiply both by x minus 1, right? So this is going to be... Now again, I haven't changed the actual ratios. I've just made them with a common denominator. Okay, now I'm just going to multiply this into here and this into here. Now remember, if that was a minus sign in front of the x, that'd be a negative x times x minus 1. So make sure you're multiplying a negative x in. Okay, I wish this question had that actually, but they didn't do a subtraction. Okay, so anyway, that would be 2x squared minus 6x, right? And then plus x squared minus 1. And that's all over my common denominator, x minus 1, x minus 3. I'll finish it off with just getting stuff together. I have a 2x squared and a 1x squared. That is 3x squared. I have a negative 6x. 1x. That wasn't good. Okay, minus 1x. X fell off. That gives me minus 7x, right? All over x minus 1, x minus 3. To finish this off, I have to say what I can't do. X cannot equal 1 and 3. Good. Okay, so hopefully I went through that, I guess sequential enough that everybody doesn't see anything there that was like, what? Where'd you get that from? Okay. Now, we're going to do division of two rational expressions. Try to do them like you did them in like grade, 4 or 5. Use the actual divide sign now. Okay? Now, we never have, it's like we got away from it for a while and now we're back with it. It makes these a lot easier if you go 2x over x minus 1 divided by x over x minus 3. So, what is division of a fraction? What's the same thing? Multiplying by the reciprocal. So then I'm going to go 2x over x minus 1 times x minus 3 over x. And I'm going to get rid of this times sign because too many, it might shove another x in there and I'm going to be, right? And remember, if only one of you makes that mistake in here, that's too many, right? So these are things you can put into place so you don't actually think another x is up there. But now, do you see how if I have an x on the bottom and the top, they can cancel? So now I am going to multiply. That is going to be 2 times x minus 3 all over x minus 1. And if you want, you can multiply that 2 in, but either one would be accepted. Again, I would get this wrong because I haven't finished the question. I want you to just take 10 seconds and write out what you believe the non-permissibles would be. Okay, talk to me. What would they be? Good. I'm going to put them in order of size, but 0, 1, and 3. Remember, just don't look at the final answer. You got to walk through the entire question. Whatever is bad will always be bad. It can't be canceled. It can't be whatever. Okay? This makes sense, this stuff? Right on. Okay, so hopefully we're getting some 6 out of 5s today. And not only is it nice to put in a 6, it's nice to go, I have no homework tonight. Okay, the perfect class would be one that you could get notes and homework done in every class. If you don't take it home, you do better in math. It's true. Oops, forgot I was taping.